So, for those of you who haven't been here before, you might have seen Otto several times. For the others, he is one of our developers that has been testing with us, and today he's going to tell us the latest updates, which are quite good.
Okay.
Please go.
Okay, Daniel. So the headline of my presentation is from the drawing to the market. And honestly speaking, it was not the way that I was waking up and say, well, it's a good idea to create a wind turbine. So therefore, it was more or less that some friends of mine have asked me to support them to create a business plan, which I have done, but they have not continued with it. And I thought it's an interesting subject, so therefore I continued with these projects. I have not started from the scratch, and not with the drawing, not with the dream, that comes later on. But the basic development of this wind turbine was done in the past by two leading companies, SMA Solar Technology, which is very famous in terms of photovoltaic modules, and Aerodyne. This is a company in the northern part of Germany who are creating big wind turbines at the moment, onshore, offshore, up to 6 megawatts. They are doing it as of today. And also University in Kassel, which is one of the leading companies, especially in the inverter technology, supported also here in this basic development. This technology I have taken over, and I continued it, and we start the business development and the product development with the testing in the field. So I packed everything what I have had, and I came here to the Folkecenter. Folkecenter I found in the internet because it's very famous. It has a lot of different varieties like waves, test stations, solar energy test facilities, but also small wind turbines. And that was a little bit difficult in Europe to find a good location. So I went here and I talked here to Tony and to Reinke about my product. They were smiling. Later on, I was knowing why, but we started. The big advantage here is, aside of that, we have good facilities in terms of workshop, for example, and know-how of the people. We celebrated here 40th anniversary last year. It's also a good wind situation. So in average wind speed up to 7 meters per second, it makes it also valuable to have testing possibilities during summer. So I came here. The first concept which I have had was a downwind wind turbine. So that was already a challenge, because a downwind we faced a big problem with after some while, because it was very noisy, I have to say. So the neighbors coming here and said, you have to stop it, otherwise it will be a difficult situation for you. It is because the wind is first passing through the wind to the tower, and then behind the tower, the rotor blade is always beating into the wind wake. And that creates a kind of helicopter noise. Yeah, so it was a challenge to get rid of that one. So we started then to completely reorganize and redevelop the wind turbine based on the basic developments by SMA and Aerodyne. So starting with the optimization of the machine unit. So it's a single frame concept. It's a little bit like an automotive area. So everything is in-house in one aluminum chassis. So we have a pole changeable generator with 1.5 and 5 kV power. We have the shaft, the gear, everything here is integrated here. We have here also the brake system. Yeah. We have here the brake system. Here below, which you cannot see here at the moment, we have also included here a yawing system, because we were trying to get rid of the noise because of the downwind wind concept. That we tested 5 different rotor blades with different angles, and in the end, it didn't work. So therefore, we changed it to the an upwind concept. We tested also passive solutions with the wind vane, but also this was not very successful. So therefore, finally, we decided here also to integrate here the yawing system. Then the tower concept. The tower concept is we have a 10, 12 meter freestanding, 80 meter Gaia lattice tower. Here we combine that it's very easy to transport. We can put all the elements one into the other. And so in total, you have a length of 3 meters. You can put it on a trailer. You can drive where you want. And it is not necessary for this wind turbine to have a crane. We can do it here by human manpower. It's no problem. This morning, I brought the wind turbine down, which is staying here. I also brought it up again. So until lunch, everything was settled. So it makes it very easy to transport this system. Rotor blade. The original rotor blade was, Anka's still smiling. The original rotor blade was a pultruded one, which is very simple because you can design the profile only in 2 directions. The big advantage is it's the most cheapest way to produce a rotor blade. You make 2 kilometers of rotor blade and then you cut every 2.5 meters. And then you have a blade. It's very easy. Costs you 80 euros, more or less. But the performance was not as we have expected. So we tested 5 different blade profiles afterwards, like I mentioned, protruded, twisted, upwind, downwind, tilt angle, cone angle. So different materials we used in wood, and we created also in glass fiber. And in the end, we decided a certain profile, a NACA profile, which gives us the best performance in terms of power performance, but also in terms of noise performance. Here's something missing. This is a nacelle, because also here, due to the yawing system, we need a new nacelle, and we created a kind of globe, which, because this one is the most compact version. We can create, for example, different designs out of it. We have one supplier who said, okay, I can put you the world globe on top of this one, on this nacelle design. But we can also create other, an art edition, for example, which you see here. So this kind of possibilities are given. But also we are doing it a kind of, if a customer is saying we want to have a kind of my own logo on it, we can very easily put his own logo here because the concept is foreseen. Until now, it was very nice, but the biggest challenge afterwards was certification. So if you have a nice design, a nice product, in the end, you have to certify it in order to bring it to the market. So some countries like Denmark, UK, USA, and so on, they're asking for type certification in terms of IEC 61400/2 or BEK here in Denmark. So we have started then with the certification process in Denmark. So we had to make endurance tests, safety tests, static blade tests, noise emission tests, load calculation. We have to make a huge drawings. We have to show the documentation with technical description. We have to show service manual, operation manual, installation manual. So I can tell you, I have quite a lot of files at home with this kind of thing. Blade testing, for example, we have done it here. You see it here in a wooden blade. Wooden blade we have taken because it's very simple to change slightly the design or the profile of a wooden blade. You take a piece of wood, put it in a CNC machinery, and then you create your profile. And then you go for testing. And if you change something, you rework it afterwards. And when you have the final design, the final profile, then you go into molding, and then you go into the glass fiber. And also here, rotor blade testing. So here we have a blade, 2.5 meter, and after 2/3 of the length, we have to make 200 kilo. We have to put a load of 200 kilo on the blade. You put it up, and it should not break. That was then the task which we have to fulfill for this one. Noise testing. As I mentioned, downwind, it was very noisy, and then we said, okay, we need a very quiet and silent wind turbine, because decentral wind small wind turbines are decentral wind turbines which are located close to the customer. So it cannot be that it is very noisy. So we tested quite a lot. It's also because in the end we have this decided here also for a yawing system. but we're also testing blades, anchors, and so on. And finally, we got quite good results, I have to say. So, for example, in Germany, we have this so-called TA-Lärm. This is the norm in Germany, which you have to respect when you make noise close in the for example, here in an industrial area, or if you go into where normal people are living in a household, or if you go to a hospital or so on. So what is the noise level you have to respect? So they are saying, for example, here the most critical one will be for old people and also for hospitals. During the day, you should not be more noisier than 45 decibel, and in the night, not more than 35 decibel. So, and if you see our product, if you go here in a distance of 100 meters only, then we fulfill this requirements. If you go here to in the industrial area 70, we can put it directly to the industrial area without any distance. So we are quite satisfied with the performance of the blades and in terms of the noise. Simple load model. Also, this one is we had to calculate. It is required by the IEC 61400/2. There are a lot of examples in the internet, and I have to say everybody is calculating it a little bit different. The requirements are also a little for standard small wind turbines with a wind vane without any yawing system and so on. In the end, we made it. It was accepted, and I have created a kind of Excel tool for it that I could also check what is in the internet, if the results are correct or not. It works quite well, I have to say. And here we also fulfill the requirements. Power curve, it's also a subject everybody is asking for. And these are real data which we have made here at the Folkecenter in 2002 and 2003. You see already here, it goes very nicely into the solar area. It starts rotating with 2.5 meter, but we start production 3.5 meter per second wind speed. Then we are creating energy. And we reach roughly our 5,000 watt or 5 kV nominal power at a wind speed of round about 12.5 meter per second. Here it's also the CP version. It is because of here that we have a pole changeable turbine. Duration test. The duration test itself is not so difficult. The problem is only to get the right wind speed. So if you're saying, okay, you have to survive 2,500 hours power production at any wind. Okay. If you say, okay, 250 hours, you need more than 1.5 average wind speed. The average for wind class 3 is 7.5 meter per second. So, okay, it's also possible 25 hours. Then you have to wait for more or less already for the autumn or for the winter season, I have to say. So it was not a problem to get the the data itself. Problem was only to get the right wind situation. And then we have to partly always to wait and wait and wait. But in the end, also this one was fulfilled by our product. So in the end, we got a certification. So our wind turbine, the Windstream 5, is sound to comply with the requirements of type certification, DEK 648, and in reference to the standard 61400. Okay. Okay. Also, okay. So therefore, we got it in line with 61422 and 61422. That was the first one. Then, of course, what have you done? It's not working. No. Needs to click. Okay. Okay. Okay, now good. So this was the certification which we need here for the Danish market in order to enter it. And it's also kind of quality mark. which we can yes say, yes, we are not developed in line with, no, we are certified in line with 61400. Then next is little. So it's not only that we need a type certification in order to enter the market, we also need the grid operator likes to know what are you doing when you connect your wind turbine to our grid. So we have to measure all these flicker, harmonics, all the things we have to fulfill, and we have to show that we are in line with the defined parameters of the grid operator. Here I have to say, in whole Europe, I would say 80 to 90% of the requirements are identical. So what we did is we made a basic certification for the German standard, and then we added the missing measurements for the different countries. So what we have done there is, for example, here with Bureau Veritas, this was a partner with whom we have done it. And we have done it here for Germany. Therefore, it is in line with VDE for 105 and with 124 stroke 100. So this is a German regulation. And based on this one, we have added additional measurements for Synagrid. This is for the Belgium grid operators type certification, what they're asking for. We have it here for the Netherlands, Netbeer. Beforehand, Synagrid was responsible for both countries, but since August this year, they are separated. So we were also looking here for separate requirements. And we do it also here for green power in Denmark. So also here we have provided all the information they were asking for. In the meantime, they have confirmed it. In Germany, it's accepted, it's everything fine. Netherlands have also confirmed it 2 days ago. On Monday, they said, okay, it's fine. We only have to provide them some data of the company. Green power is applied and Synagrid will come the first or second week of October, they promised us. So, and finally, we have a very nice 5 kV nominal power wind turbine, horizontal axis, upwind, passive stall as a power regulation system with an active yaw system, a 2-stage induction generator, which optimizes also the power generation in the middle wind speed area, 3-phase, 50 hertz for 100 watt. Now we start, that is then coming to an end. We start now with the, to build up the structure for our sales organization. I'm targeting here to have a kind of business to business, 2-level distribution system. That means I'm looking for partnerships in different countries. In Denmark, we have already one. Ulrich is also here today joining. So he has a very nice product in 25 kV. We have a 5 kV, so we align our assortment, and then we can also provide to the customer more products instead of only one. So here we see some benefits for all of us. So distribution partnership is at the moment the target for me. As mentioned, Denmark is prepared. Belgium, Netherlands, there are already very advanced discussions. Poland is at the moment a subject because Poland has started a new feed-in funding project. And Germany, of course. But in Germany, we do it directly with some agents, but mainly we are doing it ourselves for the homework. What was very important for the whole development, from the first drawing up to now, where we start now, where we have finalized our certification processes, was really a partnership here at Folkecenter. I have to say, we got a lot of support and very friendly. It's not only that the meal is very nice and very healthy, but it's also that we got a lot of support here from Tony and from Reinke. So therefore, thanks again for the time and that you have trained me quite a lot in terms of small wind turbine. So, questions?
Don't go away. There are questions? Any questions from the online audience? No, doesn't look so.
Ja, später.
No?
Mhm.
Okay, so thanks, Otto.